All right, so we get this in y equals mx plus b form. So we have 4x, let me get my pen going here. 4x minus 6y is greater than or equal to 12. We minus 4x, so negative 6y is greater than or equal to negative 4x plus 12. We're dividing by a negative, guys, so be very careful. That's going to flip my inequality. So y is less than or equal to positive 2 over 3x minus 2. So we're going to start at negative 2 here. We're going to go up to 1, 2, and over 3. This is a bold line because it's less than or equal to, and we're going to shade below it. Next one, y is greater than negative 1/2 x. So we start at 0, 0. We go down 1 and to the right 2, or we can go up 1 and to the left 2. This is just a dotted line because it's just greater than, and we're going to shade above it. Next one, y is less than or equal to negative 2. So here is negative 2. It's going to be a bold line through that. It's less than that, so it's going to be below it. X is greater than 4. So here's 4 on the x-axis. It's a dotted line because it's just greater than. Greater than 4 is this way. All right, so remember x squared plus y squared is less than or equal to 4. This is going to be a circle. My center 0, 0. My radius squared is 4, so my radius is going to be 2. So 0, 0, we go up 2, to the left 2, down 2, to the right 2, and we go ahead and connect those dots. So it says less than, so I'm going to pick 0, 0 and see if it works. When I fill in 0 squared plus 0 squared, is it less than or equal to 4? Yes, it is. So we are going to shade inside of my circle. The next one, again, my center is at 0, 0. And my radius squared is 9, so my radius will be the square root of that, which is 3. So 0, 0, we go up 3, to the right 3, or left 3, right 3, and down 3. Connect all those dots, and it says greater than, so let's see if 0, 0 works. So 0 squared plus 0 squared, is it greater than or equal to 9? No, so that means we're going to shade all outside. All right, graph each system. So look at both of these in y equals mx plus b form. So x, let me go back, undo. All right, so minus x, so we get negative 3y is less than negative x plus 6. We're dividing by a negative, so be very careful. So my first equation is y is greater than positive 1 over 3x, because there's a 1 in front of that x, over negative 2. So we start at negative 2, we go up 1 and over to the right 3. Up 1 and over to the right 3. We can also go down 1 and to the left 3 as well. We're going to connect this with a dotted line because it's just greater than, and we're going to shade above that one, but we're not going to shade yet until we do the second line. So the 2x minus 3y is greater than or equal to 6. We're going to minus 2x. So we get 3y is greater than or equal to negative 2x minus 6. We divide everything by 3. We get y is greater than or equal to negative 2 over 3x minus 2. So we start at negative 2. We go down 2 and to the right 3. 1, 2, 3. Down 2 and to the right 3. And this is going to be a bold line. And this is shading above 2. So the place where these have overlapping shading is going to be right here. The next one, we're going to go ahead and subtract that 2x. So 4y is greater than or equal to negative 2x plus 8. We divide everything by 4. We get y is greater than or equal to negative 1/2 x plus 2. So we're going to start at 2, go down 1 to the right 2. We can go up 1 and to the left 2. This is going to be a bold line. That's terrible. Let's try it again. Better. Do the best you can. And this is greater than, so we're going to be, that's above. My next line, I'm going to minus that 2x, so I get 4y is less than or equal to negative 2x. I divide everything by 4. Y is less than or equal to negative 1/2 x. So I'm going to start at 0, 0. I'm going to go down 1 and over 2, down 1 and over 2, up 1 and over 2. And this is going to be no solution. There is no common shading. All right, for the last guy, we have a x squared minus 4, so that's going to be a parabola. So if you remember, the minus 4 is not in parentheses, so we're going to move that vertex down 4. So my vertex is 1, 2, 3, 4 down. So if we pick points, negative 2, negative 1, 0, 1, and 2, and fill them into that equation, x squared minus 4. Negative 2 squared is 4. 4 minus 4 is 0. Negative 1 squared is 1. That's negative 3. Negative 4. 1 minus 4 is negative 3. 4 minus 4 is 0. So negative 2, 0. Negative 1, negative 3. And here we go. So this is going to be a bold. All right, and because it's greater than, we're going to shade above, but we're not going to do our shading yet. For the next one, we're going to minus that x, so y is less than or equal to negative x plus 2. So we're going to start at 2, we're going to go down 1 over 1, down 1 over 1. Up 1 over 1. This is going to be also bold, and it's less than. So my common shading between the greater than of the parabola and the less than is right there. For questions 10 through 11, use the values to determine the max and min of the given objective function. So let's go ahead and draw our constraints in. So x is greater than 0. I'm going to use blue for these. So x is greater than 0. That's going to be this line. Y is greater than 0, we'll do in red. It's going to be this line. Then we have 2x plus y is less than or equal to 8. So let's go ahead and subtract that 2x. So we get y is less than or equal to negative 2x plus 8. So I'm going to start at 8. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to count down 2 and to the right 1. Down 2 and to the right 1, down 2 and to the right 1, down 2 and to the right 1. This is going to be bold, and that's less than. And then we have this last guy, so I minus the 2x, so I get 3y is less than or equal to negative 2x plus 12. I divide by 3. And I get y is less than or equal to negative 2/3 x plus 4. Try to make this a little bit bigger here. So I start at 4, 1, 2, 3, 1, 2, 3, 4. And I'm going to go down 2 and to the right 3. And that's less than. So my common shaded area is this guy right here. And let's talk about all the points that make up around this. So my first point obviously is 0, 0, that I have to fill in. My second point is this guy right here, which is 1, 2, 3, 4, 0, I have to plug in. My next guy is this guy right here, which is 1, 2, 3, 1, 2. And then my last guy around the shaded region is 1, 2, 3, 4, so 0, 4. So I'm going to take a moment and plug every single one of those points into my objective function for x and y and see what has the biggest number for my max and the smallest number for my min. So 2 times 0 plus 3 times 0 equals 0. 2 times 4 plus 3 times 0 equals 8. 2 times 3 plus 3 times 2, that's 6 plus 6, which is 12. Oop, biggest number so far. and 2 times 0 plus 3 times 4 equals 12. So we have 2 maximum values, which rarely occurs, and 1 minimum value. All right, number 12. So now we're going to do our constraints first. So I'll do this one. X is greater than 0. That's over the y-axis. Greater than is to the right. Y is greater than 0. Anywhere above the x-axis, y is greater than or equal to 0. All right, let's go ahead and solve this equation for y. So we get 3y is less than negative 2x plus 12. I divide by 3. I get y is less than, not or equal to, sorry, added that myself, negative, oh, it's equal to. Okay, good, we're good. 3x plus 4. So I start at positive 4. 1, 2, 3, 4. I count down 2 and to the right 3, down 2 and to the right 3. Bold line. And it's less than or equal to, so it's below the line. And let's talk about this guy. So y is greater than or equal to negative x plus 3. So 1, 2, 3, down 1 over 1, down 1 over 1, down 1 over 1. So it looks like our shaded region, if we look at all of these, is going to be this guy right here. So let's talk about our vertices. Obviously, 0, 0 is 1. This would be another one, which is 1, 2, 3, 0. And we have one more, which is up here, which is 1, 2, 3, 0. 0, 3, excuse me. Okay, so our function is z equals 4x plus y. So z equals 4 times 0 plus 0, which is 0. 4 times 3 plus 0 is 12. And 4 times 0 plus 3 is 3. So my max occurs at 3, 0. My min of 3 occurs at 0, 3.